So in here, the core knowledge, phytoextraction means extraction by plants. And as you can see, it tells you here that plants absorb those metal ions through the roots and then they're trapped in their bodies. You burn them after you've harvested them and you collect the metal compounds from the ash. So in this example here, they've got a kilogram of ash and 142 grams of nickel compounds. Calculate percentage by mass of nickel. Well, first thing to do, let's convert 1 kilogram to 1,000 grams, and then percentage of nickel compounds. All we need to do is how much nickel compounds there are, so it's 142, divide that by 1,000, and then to get a percentage answer, you multiply that by 100. So that's going to be 14.2%. Next one, nickel is extracted by phytoextraction. State an advantage. So advantage of using phytoextraction is it allows you to use low grade ores can be used. So that means ores that would normally be wasted, there's not enough of the metal compounds in them to make it worth doing extraction by other methods. Extraction by plants does actually work in that situation. You could also say that the alternative method would be mining. So if you use this method, you would get, let's say, less noise. Be very specific in your answers here. So less noise due to no mining. You could also talk about the fact that there would be less CO2 produced than mining. So you've got far more machinery in mining that produces CO2. You've also got plants that are absorbing CO2 as they grow. So you've got lots of different things on there in that one. Okay, some nickel ores contain nickel sulfide. Write a balanced equation for this reaction. So in the first stage, nickel sulfide is heated in the air. So nickel sulfide is NiS. And if it's heated in the air, it's actually reacting with the oxygen in the air. And it tells me in here to form nickel oxide. So nickel oxide is NiO. And sulfur dioxide, there's a clue there, sulfur and dioxide means 2 oxygens in there. And then it wants us to balance the equation. So underneath, let's just put our elements and then count them up. So this side there's 1 nickel, 1 sulfur, 2 oxygens, and this side there's 1 nickel, 1 sulfur, and 3 oxygens. To make this work, we need to get the numbers the same. So I'm going to put some big numbers in front of these. Now I'm going to have a problem on this side because this adds up to an odd number. It's always going to have to equal an even number. So what I'm going to do is put a big 2 in front of that. It gives me 2 nickels, and that gives me 2 oxygens plus those 2 is 4. On this side over here, I can do 2 nickels, and that gives me 2 sulfurs. To get 2 sulfurs on this side, put a big 2 there. That gives me 2 sulfurs. That's 4, 5, 6 oxygens on that side. And if I put 3 in front of that, oh, hang on, that was okay. 3 in front of that, and that gives me 6 oxygens. Carrying on, an advantage of producing a metal by electrolysis. So electrolysis uses large amounts of electricity. That will not be an advantage because electricity is expensive, and therefore makes it an expensive process to do. Metal produced by electrolysis is pure. That's actually true. Electricity is cheap. We've just said that's not true. Electrolysis is only method used. No, we use it for actually extracting reactive metal. So the option in there that's sensible is B. And then the final little bit, we've got to explain here how we separate 2 liquids. one with a boiling point of 43 and one with a boiling point of 103. So it says describe the process. So what we would do here is we would use fractional distillation. And what we would then do is heat the mixture of liquids. So heat the mixture. The first one to boil would be the nickel tetracarbonyl because that one's got the lowest boiling point. So here we would say the nickel tetracarbonyl would boil first. Why? Because it has the lowest boiling point. So it would boil first for the lowest boiling point. And then what we would do is the gas would be condensed. So the gas would pass up through the condenser to form the pure nickel tetracarbonyl liquid. Okay,